Good morning, everyone. So my name is Qipei, and you can call me Gavin. So today I will just talk about the technologies we developed, actually funded by the 5G Living Lab. And so the title of my presentation is about integrated hardware and software for crowd sensing based transportation infrastructure management. So first, just a bit the introduction about myself and our team. So my name is Qipei, and I'm assistant professor in Department of Civil Environmental Engineering. And my research focuses on the AI technology to improve the sustainability and the performance of infrastructure and buildings. And the co-PI of the project is Dr. Mustafa, who also in this area and develop a smart, sustainable technology for resilient infrastructure system. So unfortunately, that Mustafa is sick today, so he cannot join us for the presentation as well as the file side check. And so also in our team is a company called Cityscan Technologies. That's actually a company co-founded by me and Mustafa about 5 years ago. So we already got some pre-seed funding to develop our prototype, and we already have our MVP, and we already completed a proof of concept project with our client, that Cerbert, who will join us the fireside chat later. And we have employees, full-time, part-time employees, and we get funding from different agencies as well. So let me start with our technology. So the infrastructure systems in Canada is deteriorating. And there are many, you probably live in Edmonton and the city area, there are many potholes or cracks on the pavement, and also there are different damage in the bridge as well. So the infrastructure system in Canada, actually, there are some statistics about that. A lot of damage in the existing system, and the investment needed to repair those infrastructure is at the hundreds of billions level, and certainly it's a very big burden for the government. And here are some statistics as well. That, for example, in the U.S. and Canada, that almost 20% of the roads actually rated as poor, very poor condition. And bridges, tunnels, 12%. They're just a fair condition. So here's a chart I usually use to explain why we need to do this. So we know that infrastructure systems are deteriorating, but you may think that the deterioration is a kind of a linear. For example, today is 100%, tomorrow 99, the day after 98. It's not like that. It's curved like this. So it deteriorates, but it's not a linear relationship. That you deteriorate very slowly at the beginning, and then suddenly at some point it just the performance drop significantly. And that means that if you want to save the cost, the life cycle cost for the infrastructure, you need to repair it, or to find the condition of those infrastructure and repair it at an early stage. The cost will be much lower. But if you do that at a later stage, that's almost the same cost as rebuild it. So that's how people are doing to save the cost. So to have a strategy to repair those infrastructure, the important thing is to know the current condition of them, so that we know where they are in terms of the charge, and then we find a strategy to repair them. So focus on the payment. The current technologies for payment assessment or monitoring is very expensive. So I don't know why the format has changed, but it's very expensive. And also, for example, that the instrument vehicle, it can reach the level of expenses. I think buying a car like that usually costs $1 million, and to maintain it is also a big cost. So it's very expensive and also slow. Even big cities, they won't have too many of those instrumented vehicles for infrastructure. So it's very complex and it's not scalable either. So we are actually coming up with an idea uh, that's called crowd sense based monitoring. So why it's called crowd-sensing based? Because we want to involve the general public into the process. The users of the roads, of the bridges, they're using those infrastructure every day. They are certainly very happy to contribute a bit and make their infrastructure better, right? So crowd-sensing, this concept is like a Google map. You now probably see that the Google map is very smart. You know where is the congestions and where the accidents are, right? Those are contributed by the user of Google Map. That's concept of crowd-sensing. So here's how our technology works. So we use a very inexpensive equipment. Now we're using GoPro on the back of the car, but in the future it could be smartphone, could be some in-vehicle sensors, all those things. And then we integrate AI algorithm into it and to detect the defects on the pavement. And those AI algorithms can mark the defects on the pavement very accurately. Then we load all those information we detected into our platform, and then we can do some analysis on top of that. And eventually, if we can put all those information on a map, that can help with the decision making. And now, we are actually using a single vehicle for all those things. But in the future, since the equipment needed is very simple and also it's very easy to operate, in the future, this can be done not by a single vehicle, can be done by hundreds or thousands of vehicles. Then this map can be updated very quickly, very quickly. So here's some other features about the platform we developed that can give the rating of the conditions, and we can give a very detailed image about the payment we assessed. And now we are partner with our actually with our client that to develop some other technology, for example, to check the curb and gutters and also to check the trails. So about the technology we developed that, so we did some business analysis that the total available market for infrastructure asset management is actually huge. That it can reach the US dollars of $85 billion by 2032. And the transportation segment only, it's almost 30% of it. So if we only look at the payment itself, the total available market in Canada, it's about $2 billion per year. $2 billion per year. So this we have actually thanks to the funding of the 5G Living Lab and all the other funding agencies. So we have moved forward with the commercialization. So for example, we have actually clients, City of St. Albert, City of Kelowna, who truly trust in our technology. And we have Faida and Isaac from the City of St. Albert who will talk with us. And we got done some demo project with different cities in Alberta and BC as well. And of course, very thankful for the funding from 5G Living App to help us to move to this step. And of course, there are many other people and many other funding agencies help us as well. For example, the very original idea of this technology was funded by Alberta Innovates Graduate Scholarship. And we developed the prototype, and later we got funding support from NRC RAP, from NSERC as well, to further pave the road for where we are right now. And so very thankful for them. So a bit more about the technology we developed. So this is the AI technology we developed, and compared to some other, let's say, commercially available technologies, so some other laser-based technologies can only detect those defects at a very rough level. For example, draw a line or bounding box to detect the cracks. But now what we can do is actually get a pixel level accuracy for those defects. And also we are developing some LiDAR technology to actually scan the cities and to get more information about the infrastructure. So also because of the project funded by the 5G Living Lab, we have a chance to develop hardware as well. So this is actually the first generation of our technology or hardware. That was 6 years ago. 6 years ago, it just 3D printed and we put sensors inside and we test it out. And that's 5 years or 6 years ago. And now, because of the funding supported by the 5G Living Lab, we got the chance to improve the technology and include the actually 5G technologies to even better help with what we do. So now we get a chance to just improve the sensors. We get a different stand to support it. We get LiDAR, we get GNSS, all those things integrated. And eventually this will be powered by 5G technologies for better data transmission and real-time data analysis. So here's where we are right now. And in the next steps, we will continue working on what we are doing. And we will try to integrate decision support capability in our product. And also we are trying to enhance the real-time data transmission in the product. That relies on the capability of the 5G Living Lab. This is an essential part of this because now we're using one vehicle. What we do actually just take the SD card out and do the analysis. But if we want to really achieve the crowd sensing concept, it has to be 5G, has to be a real-time data transmission in the future. And also we will expand the product and try to evaluate, for example, other real-time events on the road because we have an instrumented vehicle. There are many things that can be done. For example, we can detect other accidents on the car on the roads, or we can find many other things like self-driving cars or other things. So thank you very much.
All right. Well, thank you, Qipei, for that engaging presentation. You co-founded a startup. I know you're a co-founder, Mustafa. And it really seems like from your presentation that the core vision of CityScan Technologies is to develop innovative solutions, ones that combine best engineering, civil engineering practices, and leveraging emerging technologies to make them accessible to communities like the city of St. Albert. So we have Faisal here today. I'm really excited to hear more from your perspective as the Infrastructure Transportation Engineering Department at the city of St. Albert. Can you share more about the historical and current practices around road and pavement management?
Sure. It's maybe not the most exciting topic of roads. I'm sure everyone hit a pothole or a bad crack on the way here. So, I'll apologize on all civil engineers. We build it that way. We make sure our jobs exist forever and ever. We can't build products that live forever, and it's a nightmare. It truly is. It's a real life problem in the sense that, for maybe some of you that don't know, Edmonton was founded on the bottom of a glacier lake. So we have the poorest soils. We've ran out of rock about 20 years ago, so we ship it in about 150 kilometers away. And so we have the worst materials and the worst climate for roads. So we are a very good testing ground for material science and road performance. So I think the things to think about when it comes to roads is, and even working in a municipality, I have, when I was working in City of Edmonton, I had 1.5 million bosses. In St. Albert, there's 73,000 people, and those are all my bosses because they will tell me what our service level should be. And engineers are very bad at communicating back at what is that service level that is maintainable. So managing $1 billion of assets then becomes an issue of who's using it, So I'm sorry, I forget your name. Mo's maybe one of the younger people in the crowd. So if Mo likes fancy cars and doesn't have a family yet, so he wants roads to be fast, smooth, whereas, maybe some more family-orientated people want it to be slow, don't care if there's a pothole because it slows Mo down in his fancy vehicle. Very interesting conundrum of how to manage our assets. So the question, I guess, is, well, first of all, the reason we don't want to rebuild these defects into our roads is just inherent of what limitations we can provide at that cost. So you can imagine how expensive a road and bridge is, roads are technically, we designed for about 20-year life cycle. So the surface really only exists for about 10 years, and then you have to learn to either preserve it or replace it. So that pavement preservation has become a hot topic because it's a very specific and sensitive ideology. So if you buy a new car, how many out there would want to get the 3M coating? I think it's pretty expensive, but if I'm buying, a $500,000 vehicle, I'll spend the extra money to preserve that paint. If I'm buying a used vehicle, would you put that coating on that car? And that's the concept of pavement preservation is, I think in 1956 is when in Illinois they created a road test tracks. This is how civil engineers like to do things. We had a lot of people coming out of the wartime, and we had a lot of vehicles, and they had a lot of personnel. So they said, okay, for 24 hours, we're just going to drive vehicles around this track for about 4 years. 7 miles of track, built different types of pavements, and that's how they evaluated what works and what doesn't work. And models were built from that for pavement design. But the concept is, it's too expensive to allow the loading from the vehicles to be built throughout the materials. So the loading is going into the subgrade. So the evaluation of the subgrade and each layer is kind of how you're looking at it, no different than building construction. You break it down into its elements and you look at what can you preserve to keep that building alive for another 100 years. So with pavements, you have the surface layer that you can protect. That's probably what Mohammed wants the most. I'm sorry, I'm picking on you. But it's that concept of, so traditionally we evaluate roads with the ride, which can be done with, on highways. It's a very sophisticated product. It's been around for many years, down to using cell phones and the accelerometer in a cell phone to pick up the general ride of the road. Then you have surface defects. So that would be potholes, cracks, and that's often picked up by LiDAR information. So LiDAR has been around for a long time. It's an amazing product for us. You can drive 100 kilometers an hour and pick up every feature you would want on that roadway. So moving into more municipality, it's different of how the roads behave and perform. You have a lot of stop-start traffic, so that allows running into your environments. So the most important thing is Qipei has alluded to is what is the condition of the roadway currently, and where is it on its life cycle? And that becomes what we will disagree, because in reality, pavements will never, we don't have that crystal ball to tell me, okay, I built my pavement, it will start failing at this end, at this time, from this method. So from the 1960s, there was a software that every engineer used, and it had 7 inputs. So how much traffic do you have? What environment are you in? What type of material are you going to use? And you would design a thickness of a road. So now with new softwares, we have a more mechanical, empirical type of way of analyzing it. I think it takes up to about 130 inputs. It uses NASA's weather data to tell me, okay, if I press enter and I run my module, my pavement will crack from bottom up at year 35. So it's very interesting of how scientific it can get, but is that real? How do you check it? And I think that's those performance curves that most pavement design softwares are being used, or pavement evaluations, it's not real. So the amount of money used for this road construction, so I will say that to rebuild a pavement is 10 times the cost of just resurfacing it. And all Mo cares about is that it's clean and resurfaced. So if I resurface a road, I'll get maybe 10 to 12 years out of it. So you think about Alberta transportation and highways and bridges, bridge decks aren't lasting that 10 or 12 years. The highways are being microsurfaced, which is a treatment that you can just put a little bit of paint on top, and it improves the ride, seals the road, but how long does that last for? And so it's a very interesting puzzle to find, here's your road condition, this is the right investment to put into the road. And it all comes down to that evaluation of how is that road performing now, and where do we think it's going to be in 10 years?
Absolutely. So you mentioned a number of kind of problems that could potentially be solved with some of these emerging technologies like artificial intelligence or IoT or augmented reality, computer vision, potentially 5G. In Qipei's presentation, he mentioned a partnership with the city of St. Albert. Can you give us some more background and insight of how did that partnership come to be?
I think it just came down to a few individuals, no different. I used to be part of a very big talking tour talking about pavements. My God, think about how boring that would be. But it was interesting because a lot of civil engineers are relying on ASTMs or best practices done around the world. The thing is that stops engineers from thinking outside the box and evaluating it for what it is and using your professional judgment to move forward. So the idea of digital twins was a big concept of we're already using LiDAR. Why aren't we using this digital twinning to keep records of our as-built? Typically a city would just hold paper copy or PDF copy, and having that digital twin of the city allows for a lot of cross-asset optimization. So I think that's the new buzzword, is how do we, as the managers of these assets, make sure I'm not going to resurface a road before I replace the pipe underneath it. And so that idea of having a digital twin was very interesting. And so that was something that CityScan was offering at the time. And unfortunately, that's not something that I really care about. What I cared about, if I take an image of my roadway every day, every month, every year, currently it's so expensive and the data that we get from it is so sophisticated, I don't really need all of that. It was to define the behavior of the roadway. So every 3 years, I miss a big gap. Our roads, everything in a geotechnical common sense is that the whole world is moving up and down, especially in our winter environments, by about 2 inches. So you can imagine that any hardware in the road, any different materials won't settle and expand in the same fashion. That's why you're going to get cracks. All the manholes are heaved. So having that regular image gives the potential of truly defining that performance curve of a roadway and understanding what life it has left in it and the different layers and what is valuable and what is something that is better replaced.
Absolutely. Well, I'm excited to hear about this partnership with the City of St. Albert, especially from the startup perspective. It's very important that we have industry and government and collaborators who are working together with us to launch pilots and programs that take things from the lab out into the communities that have real impact on others. So, Qipei, can you tell us a little bit more about the first generation of solution that's currently being tested as part of your partnership with CityScan Technologies?
Sure, I can talk about that. So, yeah, that as mentioned, this technology, the concept actually was from my PhD thesis. That's almost 6-7 years ago, and we have tried to improve the technology, improve the AI technology, different sensors, try to build that hardware. That almost took us 2-3 years to get to acceptable stage. And fortunately, we got the partnership. I would call it partnership, strategic partnership with the city of St. Albert. That because we are way more beyond just let's say the solution provider and the client relationship. Because we have meetings almost every week, try to define what their needs and try to understand the market, understand the city's needs, and try to refine our product and to improve it. And so during this process, that's really help us to shape our product into a actually market ready stage. That so this partnership and process really help us.
If I can add, I spent 20 years working in the city of Edmonton, and you quickly realize that a municipality at that size, it's very hard to introduce new concepts. Your stakeholders being the residents and council, it is a big ship to turn. So the lucky thing when I moved to St. Albert was it's a small enough community with high enough expectations. We don't, in St. Albert, we always complain about we don't want to be the bedroom or the bedroom community of Edmonton, or the sister city. So we've always prided ourselves on, adaptive technology, whether it be in traffic or in pavement design. So it was an opportunity that I'm realizing now is fairly rare to have the opportunity to work with somebody wanting to push the technology and also a city or municipality that was open to finding new solutions.
Absolutely. It's wonderful to hear how open the city of St. Albert has been to kind of driving innovation and testing some of these ideas as well. And kind of speaking on the topic of innovation, it gets me thinking. I know, Qipei, in your presentation, you mentioned you're working on you have a software component to your technology, but also a second generation hardware component. My mind is curious and goes to kind of imagine some of the possibilities of how this existing technology could be advanced, incorporating 5G and network capabilities. Perhaps things like computing in real time or crowdsourcing. What other advantages do you think you could foresee in the future around 5G?
Yeah. Yeah, thanks for the question. So certainly, our hardware development has actually largely benefit from the 5G Living Lab funding and through the 5G technologies. So as I mentioned, the initial data collection, all those things, we do it in a very manual way. We have GoPro, we take the SD card out, and then we do the analysis, we put it back. And so that actually limits the scalability of the technology because you just imagine you have 1,000 cars. You scan the city every day. You cannot just ask someone to take the SD card out 1,000 times, right? So it has to be actually 5G technology because other technology is not the transmission speed will not be enough to handle the large amount of data we collected. So 5G technology definitely will enable us to achieve that crowd sensing concept and to collect all those data in almost near real time. And also, this also opened doors for other applications. Now we have more focus on the payment, but the same technology, the GoPro, the camera, or the LiDAR system on top of it, we can easily add other sensors on top of it. And this can enable us, especially the 5G technology, can enable us to focus on some other like important events that the municipalities or the cities are interested in. For example, the real-time car accident or some other violation of the laws or something like that. So that can give us more opportunity for other markets as well, even though we haven't fully explored that yet, but give us a lot of possibilities.
Definitely. That's great to think about. And that kind of leads right into my next question, as that's what I was thinking about, really, truly, in terms of coming from the startup space. I always think about what other applications are there, or, how might this technology impact other sectors, or how we might be able to solve problems using this technology. So I'm curious if you could share more about some other problems potentially that municipalities face that could be advanced by this technology.
My nightmare, because it's not the most interesting asset, is sidewalks. So if you can imagine, when you have your home, that frontage of your sidewalk is your sidewalk. Is it? Or is it mine? Or is it the municipalities? Who decides on that service level of your sidewalk? So currently, and I worry about our children because our policy now is sidewalks have to be a vertical tolerance of 10 to 12 mils. That means any displacement above my finger is now a hazard, which is pretty crazy level of service when you think about it. Especially when everything is moving up and down every season, every subgrade is different. So the idea of using that technology. So, I'll jump right in. One thing we're really excited that we asked CityScan is, okay, we understand this conceptual idea, but the biggest problem we have is our curb and gutter. It is a large asset that is kind of orphaned, and we don't have the tools to really look at the grades, the condition, and prioritize it with roadways. So it really disconnects our reconstruction side of things, or rehab. So that was one of the nicest advancements, I would say, is just the curb and gutter evaluation. can be confirmed in the field with a level and a tape like we've always done for the last 100 years, but to be able to use LiDAR and map it and create programs for us and prioritization. So I guess that's the big thing that we are looking for in a municipality is how do we prioritize? Because the moment I pick a road, my council member would say, well, why not my road? And why not my sidewalk? And so it's that ability to see, one thing we see is the crowdsourcing of cell phone data to see trip generation. Where are the average people driving, traveling, biking, walking to help us prioritize our assets? Because fundamentally, we start with function and safety. Is it functioning and is it safe? So those are our top criteria. But, if it's a trail out in the forest, does it really require the same service level as a trail downtown? And so those are some of the things that we're looking for.
Yeah, thanks. And I can also add some other things if you want that from research side. Actually, some research Mustafa did. For example, he's using similar technology and looking at the welfare of the cities. Like they can put the same kind of sensors powered by 5G technologies, and then we can try to classify the type of trees and identify the risk level of those they call it fuels, and then for the files, and then also this can help with some situation like a post-disaster. Right? If something happened, you have this technology. 5G give you real-time scan of those situations that will really helpful to, for example, first responders, right? All those.
That's fantastic to hear. And I know there's a lot of exciting research being done around emergency and wildfire evacuation management, especially leveraging technologies like AI and 5G. So it sounds like this is kind of just the beginning for us with this technology. And I'm really excited to hear more and see as this partnership continues with the City of St. Albert and how it might be utilized in the future. So I think we're approaching our time. I'm going to thank you guys again for joining us today in this discussion, and I'll pass it over to David.